the background to it. So like I used to be a .NET dev 10 plus years ago before I got into InfoSec. And we find just quite a lot of .NET vulns and .NET related stuff on engagements. Like there was a huge push for people to move away from Java to .NET, especially within UK companies, sort of, yeah, within the last kind of 10 years. There's quite a lot of big orgs had some like obsolescence programs to, get rid of Java, finally move to something modern like .NET. So we see these apps like internal apps and like third-party things that they are around. They often have creds and other kind of interesting stuff in them. So pulling those apart as part of the work we do and seeing like how they work and what they're doing and everything else is often interesting. And yeah, there's been a couple of interesting vulnerabilities in Microsoft signed .NET apps over the years as well. So there's the one that we were going to look at in this blog post. And then there's been some related stuff that I think Netitude published a while ago now, but both of them were related to deserialization issues in .NET assemblies and .NET binaries. The reason why we're looking at Microsoft signed ones in this, if that wasn't clear, is if you have a binary signed by Microsoft, it just has a lot of trust associated with it. So like if you find that on an endpoint, it's normally kind of in like AV exclude lists, or it's treated with less scrutiny than a random .NET binary from a different signer, different publisher. And they tend to be, especially things like the ones we're looking at, they are on like all the Windows endpoints. So they are kind of useful if you can find vulnerabilities in them. We can do interesting stuff like initial access and lateral movement using those binaries that are already on disk. So yeah, the first thing we need to do is like teach AI how to reverse binaries, right? Like it has some understanding of common vulnerabilities in these libraries. It's been trained on a lot of different sources of information. So it will understand, broadly speaking, what deserialization is and the sort of different sinks for deserialization issues in .NET. It knows what gadgets are and these kind of things, but it doesn't have the ability to take a binary and turn it into something else. So that's the first thing, the first problem that we need to solve with this. And the sort of obvious way of doing that, at least when I first wrote this post, was with MCP. So yeah, you can extend AI. For those of you who don't know how this works, you can extend an AI agent with an external tool. So you tell it how to call an external thing, and it enhances its capabilities. So it has a common protocol, the MCP protocol, that it will talk to other stuff, and then you can give it essentially anything you want. If you build it, you can give it servers to do whatever you want, and give it the ability to do things like internet browsing and reverse engineer .NET binaries. Normally, I would do this with .peek, right, which is this one that's linked out here. This is a really nice GUI application. It's the one I tend to use because it has a symbol server built into it. So you can disassemble a binary and then you can serve its debug symbols and use those in Visual Studio to help you do debugging and stuff with it that way. But yeah, we can't really use that with MCP. Like it's a command line syntax. It runs without a person clicking stuff in UIs. So yeah, we need something else. It turns out somebody has already made ILSpy CMD. So ILSpy is a big app, but it also has the command line version, and it can be run on Mac and Linux. So we can package that in Docker. Again, somebody has made one of these before, so the link to that is here. When I looked at it, I've not looked at it since. There was a couple of issues with that Docker file, but yeah, the fixed version is in the blog post, so it's quite easy to fix, especially if you just feed it back into AI, right? Like the AI understands the error messages that are coming out of there, so we just need to tweak some different versions and things like that, and then you can run this fairly small Docker container, and it will work and run, and it will take input and let you do other stuff. So yeah, this is kind of the first step here is getting that up and built. I mentioned here that we're using the same framework that we used in the previous blog on this. So we're using FastMCP. That's still what I'm using now. It's still what's going to be in the kind of, modern, let's say modern, newer way that I'm doing this. We'll get to it in a little bit. It's just a framework basically that abstracts all the kind of under the hood stuff that we don't need to worry about. So we can just write some fairly simple code. So the way this works, you give it a basic prompt, just kind of telling it what this MCP can do. And then you give it the command. In this case, we're taking the exe path and the output folder. And that's all this does. So you can tell the agent to disassemble this binary and put it in this place, and it will call into this MCP. This will just do some Python to get the absolute paths and things like that from whatever you give it, and then it will call into our container, which is down here, and it will just run the Docker command. So that will go off to Docker. It will do the thing. ILSpy is pretty quick, so it doesn't take too long to get the disassembled code out of this, and then it will just write it to a file somewhere, and then you can continue with whatever it is you want to ask the agent about the .NET code that you have just disassembled. So that's the first step in this, is giving the AI the ability to turn an exe into source code. And we could do this ourselves. I mean, this is not a difficult process. It's a couple of clicks to export these to project files and stuff like that in most of these disassemblers. But the reason why I wanted to automate this is we can do this now at scale and without kind of operating in the loop, which we'll get to a little bit later on. But there is a reason why I wanted to automate this step. So then we need to tell the agent how we call this. So this example is with Claude. I'm going to be using Claude code later on for like the newer way I'm doing this. But this will be fairly similar in whatever like agent system you're using. You need to tell it how to use the MCP. So for Claude in the desktop app, you edit the Claude desktop config file, and we will have something like this. So you have this JSON format stuff where you have the MCP servers block, and then these are ones that I added in a previous post back when Claude didn't have this capability. Now it does. So Claude can go off and reach out to the internet now. It can do file system interaction inside its own VM now. When I wrote this, it couldn't, so we had to extend it with these like extra bits just to let it go and read files and do web searches and stuff like that. So yeah, this is a little outdated now. And then at the bottom we have our ILSpy block, and we're just running it with UV. That makes it quite nice and easy. We just tell it the full path to UV, and then this is where the Docker file lives, and we're just telling it to Docker run that, and it will run the ILSpy Python that we had up above, and that's how you like tell Claude how to use its MCP. And then once you restart Claude Desktop, if you get everything right, it will be in there as an MCP that it can use, and you can see some of the other ones that, again, I'm not using these other ones anymore. They are superfluous now that Claude has had a few updates since this was written. So then this is one of the more interesting vulnerabilities that are public. So, obviously for various reasons, we're not going to talk about anything that's actually a node A in this, right? So this was published in 2023 by Blueprints, and it describes a .NET Deserialization issue in adding-util, which is a Microsoft signed binary. It's on every endpoint. It's still there in Windows 11. And it has two issues that are mentioned in this blog. One of them, they go through and do the full kind of blog post thing and go through all the code paths and get you a working exploit at the end of it. And the other one, they leave to like an exercise for anyone who's interested. So the first test I wanted to do with this is just see if Claude could actually find the issue that was already out there. And I don't know if Claude has been trained on this blog post or not. I didn't give it this blog, by the way. This was done blind just for like the science experiment. So yeah, we start asking it some prompts, and these are probably not the best way of prompting Claude. This was the early days of me really starting to use Claude and experiment with it and figure out the best way of kind of guiding it through this kind of thing. But it gets the job done. So first of all, I'm checking that it has the capability and it understands what it's able to do with that MCP. And then I'm doing this on my Mac, but I have just grabbed the add-in DLL and given it to Claude. So what I didn't do here is have it figure out that this system add-in DLL is called by add-in util. It should be obvious for it to figure out from the decompilation, but also at the time, and I still am in the background working on something sort of bigger than that, which we can get into in a little bit, but like a way for you to map the dependencies between different .NET DLLs and the calling classes and stuff like that using Neo4j. So I just for the sake of the blog post, choose to ignore that step. Yeah, so it recognizes that there's a DLL, and I'm telling it to decompile it to this specific path, and it will go off and do its deserialization, decompilation. So it will run it through the MCP, and it will get all of the decompiled files out of it, and it will be able to read the source code. So then we'll start asking it to look for issues in there, and it will eventually start finding unsafe binary deserialization. So this is what we're wanting it to think about at this point. This is the issue. It is passing user supplied data into binary format, but the challenge here is can it figure out that there is a path from user supplied code to this call, right? And it starts to get that kind of that there's an issue there, like it calls it out. But you have to put a lot of effort into kind of steering it towards, specifically look at deserialization vulnerabilities. It will give you a full vulnerability analysis of this thing. The one it found up there is the add-in process one, which was published by Netitude, by the way. So it's in the same DLL, just used by a different exe. And it failed to find it again. So at this point, you have to start asking it questions that you don't think you should. So, like, did you read every file? And it will tell you that it read some, and it skipped over a lot of the different files. So it's not going to lie to you. It will tell you when asked directly that it only reviewed 14 files, and there are a lot more than 14 files in this decompiled binary. So you have to tell it again to go and read, all these files, make sure you've read all of them, focus specifically on deserialization vulnerabilities, go and look in these places, do it properly, don't skip over it. And then we'll get to this point where it will identify the known vulnerability. So it will find this call, it's seeing that it's doing the read cache call, which is where, if you read that blueprints blog, this is the entry point for this unsafe deserialized call. So it will, you're taking this user supplied data at this point in the read cache and dropping it into binary formatter. For those of you who might not know .NET, this is inherently unsafe. There is no safe way of passing user supplied data into binary formatter. Like, it's not like some of the other deserializers where you can turn off type resolution and stuff like that. Like, if you pass a serialized object into this, it's going to do bad things, basically. And then, it's starting to find the issue now. It recognizes that the cache file is potentially untrusted, and then we can start giving it a little bit more information at this point. So we're going to tell it that the DLL is referenced by add-in util. And again, could get Claude to figure that out by itself. As a slight tangent, when I wrote this, the usage limits in Claude were done differently to how they are now, which is something we'll get to when I show you the kind of different way of doing this. But I was a little more free and easy with the prompts in those days, and not hitting the limits quite as often as I tend to like now. So yeah, for the sake of the blog post, we'll just tell Claude that. And I do say that this will be a subject of a future post. It will be. I'm just still working through that. So again, we're telling it, we're using this binary formatter and we're looking in the add-in store, and it will go away and decompile add-in util, and it will figure out the entry points and stuff like that for you. I say thinking in here.
James, if you have a second,
yeah.
we have a couple questions.
Oh, sure. I don't actually have Discord like open. Sorry, I'm reading the blog. Yeah.
Oh, you're fine. That's why I'm here. Was the Claude Code Pro account enough for all that you've done with this? Did you leverage Anthropic API?
No, so this original post was done entirely in Claude Desktop. Let's say this was a while ago, so the usage limits were, calculated much differently than they are now. So it wasn't using Claude Code. I don't think that had been released at this point. If it had, I certainly wasn't using it. The version I will get to shortly is now in Claude Code for a few reasons. But yeah, this was all done in the desktop app.
Okay. And then from the beginning of the presentation, not really related to hacking, with installing all these tools, cloning repos, connecting various MCP servers, how does one keep track of them all?
Yeah, that's a good question. I don't use that many, so I just kind of remember. That's a terrible way of putting it. You can list the ones that you have installed in Claude. Like there are settings menus that will tell you which ones you're using. The main thing to note with those is not necessarily how many you have. It's more where they came from, and being aware of like there are. If you pull down an untrusted one, this is in the Anthropic box somewhere, if I remember rightly, but they can, they are running code on your system. So make sure you trust the source of those is probably more important than how many you have. The way that usage limits are calculated now, it will use context every time it uses an MCP. So it's probably worth, if you've been experimenting with them, going through the list and just kind of making sure you don't have any in there that are being used that you don't need anymore, because it will be chewing through some of the context allocation you have.
Great, thank you. Reminder to everyone, feel free to send questions in chat. Yeah, I'll let you get back to it.
Cool, awesome. What we're looking for here is what was hinted at in the original blog, that there's another issue outside of what they talked about, which is in pipeline root. And it's left as an exercise to the reader. So now we wanted to find out if Claude was capable of finding that, which is arguably not an O-Day, but there wasn't any public POCs for this out at the time. So I'm calling it an O-Day for clickbait reasons in the blog post. So it will go through, and it is capable of finding this code path through the two files now, so it has access to add-in util and the DLL add-in util references, and it will find the attack path for us. So it will tell you the flag that you need to use and everything else. So what we are asking you to do then is build a proof of concept for it. Now, this example is a little bit more complicated than the one that was in the original blog. Like you can, for the original one, you just send an add-in.store file, give it the add-in root location, and it will add-in util will just know how to do that. The pipeline root folder, it has a specific folder structure that is not impossible to figure out from the source code, but it's not as straightforward as just here's a file and it's a serialized object with some padding and it just works. So this was at the time, for the sort of where we were with AI models, and this was a fairly good test of its ability to figure out from the source code what it needed to do to build a working proof of concept. So yeah, it did generate some code. I didn't put it in the blog. I'm kind of the opinion that if you are reading this, you're capable of reproducing the steps, and if you just want a free tool to do some bad stuff with, well, I'm not going to give it you in a blog post. My conscience is clear with that decision to explain how to find it and not not actually released the tool to do it, but it will give you the code to generate the stuff that you need to build a working exploit. And it's doing a lot of this kind of building of the exploit has some padding around it, which is what this is doing. It's adding padding to the front of the binary formatter serialized object, so it fits with some checks that are in the code. So we'll get Claude to explain this as well. So yeah, this. Sorry, I'm reading this and trying to explain it at the same time is interesting. So when you disassemble this code, you don't have the same context that you would have when you wrote it, right? There are some things missing, like comments and stuff like that. So all we really need to know is that there's padding on the front of this blob to make the deserialization work. So when you pass the add-in store into add-in util, it will strip off the first 8 bytes or whatever it is of the file, and then it will pass the rest into binary format to deserialize. So if you don't do that padding, it will break the object and your exploit won't work. Getting Claude to explain why this is done is actually quite interesting. It tells you a little bit about how it kind of thinks, for want of a better term, about these like pieces of code that it's reading, and it will try and rationalize why this decision was done. And it's essentially guessing, right? Because there's not enough context in the code to fully understand why it's doing it, and it'll guess at the purpose of those 12 bytes. But yeah, as they're not used in the decompiled code, we can't tell you if it's actually the right reason or not. But yeah, so we are going to try and find the path for this pipeline root stuff, and it will it'll go through and it'll fully explain it to us, and then it will build the POC. And I'm giving it the gadget chain here, like in the when I'm executing the payload. So I'm not having Claude build these gadgets. It at the time didn't really care about mentioning things like why so serial. Recent Claude is very anti why so serial for some reason. There are some things that it just doesn't like to talk about, and whysoserial.net is one of them. Even though you can have it build like working exploit tools for you, if you say you're going to use a whysoserial.net gadget, it will like shoot you down and not want to discuss it. So stuff like that, I like known exploit tools I tend to keep outside of my Claude context. And then yeah, it will build you this tool, and it will quite happily give you everything you need to do it. So skip through this bit because this is just kind of doing a little bit of debugging, but essentially just running through some issues that Claude missed manually in debug mode. This is not how I would approach this now for the blog post and where we were with AI at the time. Yeah, this was kind of where I went to. Now I would just have an agent look at it on my behalf. But once we figure out what that issue was and kind of get Claude to figure out why it had gone wrong, make a quick update to the code, and we can see it's now popping calc from binary formatter through the add-in pipeline flag that wasn't mentioned in the original post. So yeah, going through and getting Claude to analyze code and figure its way through it and build a working exploit chain was kind of the point of this post. So as I've alluded to a couple of times, things have changed quite a bit since this was published. So let me swap the screen that I am sharing. To stop that one, just restart it, I think. Yeah. We'll share Claude code. I can find that one. There we go. So you should hopefully be able to see a Claude code window now. Please shout if you can't. So there have been a few developments since this post went out, right? We now have Claude Code. The models that Claude are using are better, arguably. They've changed the way they do pricing and the sort of context limits that you have. So I am on a pro account, the $20 a month, basic tier, and it used to be that you could use that pretty much all day without really hitting any limits. Now there are 3 different limits. You have a it's daily or weekly limit on how much context you can use, and you also have a couple of limits per model. So one of the more intensive models is treated separately and has its own lower limits, and the sort of less good ones are they have bigger limits on. And Claude Code fits into this usage pattern as well. They're shared between Claude Desktop, Claude Code, and API usage and everything else. The other thing that has recently been released is skills, and skills and MCP are different, but they do complement each other. So this is something I was kind of working on for the last few days, but mostly for this talk. And we're still using the same MCP, so I've still got that Docker file doing IL-spy. And that is configured now in Claude Code as just it runs it with UV. I have actually changed how that's capable of doing things a little bit, which I should be able to show you in here. Yeah, there we go. Let's just move that window over so we can take a look at it. It's still calling into Docker, but I've now updated it with AI's help to automatically deploy the Docker file if it's not running. I use OrbStack, so Docker, OrbStack, I'll probably use those terms interchangeably. If it tries to do Docker run and the volume it isn't there, the container isn't built, whatever the issue is, it will just run this Docker file. So we'll Docker build it and start using it. We had a couple of checks just to see if the image exists, if the image is running, whatever else it needs to do. This code just goes and builds that image. Some more stuff to initialize it. Whatever else we need. We have the setup prompt. So this is essentially the same thing. You're telling it that it can decompile files and write them to an output folder. And then we have the actual decompile step, which is doing the same thing. And it's writing to whatever file. It just has a few more checks around it and stuff. I've also added a couple of checks. I say Claude added them, but I told it to, so I'm claiming credit, just to see if they're actually .NET binaries that we're trying to get it to deserialize, just so we're not trying to throw Windows native binaries into this thing. So that is essentially the same. It's just been updated a little bit since the block came out. The interesting thing is the skill. So skills are fairly new. I think it's within the last couple of months that these were released by Anthropic. And they have 3 parts to them. You have this initial block at the top, this short description, and that tells Claude what this skill does. Skills provide extra knowledge to the AI, so you can enhance it with a skill. The kind of examples they give in the documentation are things like teaching it how to do your company's branding, for example. So you can give it a skill that has all your color palettes and your branding guidelines and whatever else you may need. And this description would be use this skill to apply corporate branding to whatever documents I tell you to. And then it will use that skill to go and look up whatever rules need to be applied, apply those to documents that you ask it to produce. That's the example. But we can also use it to do stuff like decompile .NET assemblies, right? Like we can tell it that it's able to use this MCP to decompile them. We can then tell it that we're going to focus on vulnerability and security analysis, vulnerability research, malware analysis, understanding application logic, those kind of things. So this big sentence is loaded every time that Claude is loaded. It uses minimal context, so it just gives the agent enough background knowledge about the skill for it to know that, oh, I'm doing .NET decompilation, I'll load other parts of this skill, or this skill relates to corporate branding, so I'm doing malware analysis today, so I don't need to load any more of that skill. So it minimizes your context usage. Then you have this bigger block down here, which gives it more information. So if it reads this and it gets a task that it thinks it needs this skill for, it will load this next block. And that gives it just more information to work on. So it gives it more details about what it's for. It gives it some prerequisites like the MCP server. We also tell it how to start the MCP server somewhere else. We give it examples of how to do decompilation. We tell it what to focus on when it does analysis. So we have the steps, like first of all, you have to extract the source code, then you review it, and then we do targeted analysis, and then we do findings documentation. Common use cases, we document the kind of things that we might be interested in. So for security research, we decompile the main assembly, we look at authentication, authorization logic, hard-coded creds, SQL injection, insecure deserialization. And you can increase this list or tweak it to suit whatever research you're doing. But for a security-focused assessment of a .NET binary, these are the things that you would be more than likely most interested in as a quick win on a red team or whatever else you're doing. If we're doing malware analysis, and this we'll handle both if that's something you're interested in. You will probably want to look for other things. You're more interested in IOCs, documenting capabilities and stuff like that, rather than actually finding vulnerabilities in it. Application understanding, we tell it, we want to map the architecture, we want to look at third-party dependencies, understand business logic, configuration patterns, those kind of things. And then we have some other capabilities that it's able to do. So we're going to see this scripts folder referenced. I will go into what that is in a minute. But we can have it batch process assemblies now. So I can give it a folder full of .NET assemblies and just say, go reverse all of them. And it has an ability to do that now. And then we give it some more information about using namespace filters to focus decompilation, extract only specific classes or methods or whatever other things that we put in here to kind of help it do its job better, essentially. So we're not telling it, why we're doing, looking at .NET deserialization. We're not explaining deserialization to it. We're telling it how to focus in on finding the issues that we're more interested in finding. We tell it the structure of the output folder that we want, so it will build this folder structure for us, which you see over here somewhere. And then, we have this kind of documentation stuff where it will go away and look for these things using scripts, which again, we'll cover what the scripts are for and how they work in a minute, but it's going to use this script to find some hard-coded stuff. This is still in the proof of concept stage, so this is a hand-built by Claude script for finding sensitive information in files. There are obviously better tools for doing this, and you would be looking to integrate something like Nosy Parker or one of those kind of tools into it to kind of further enhance that capability. But I wanted something to show you guys for this. So a quick proof of concept is really all I have time to do at the moment. But just know that you would be expanding this with other tools. We have some more scripts to do dependency mapping and stuff like that. And then we tell it how to fix trouble, fix issues, common issues and solutions, Docker not running, start Docker, permission denied, make sure you have permissions, these kind of basic troubleshooting steps that we can have this thing do before it panics and has to ask us to do stuff on its behalf. And then we tell it about scripts. So we have the MCP, we can have an ability to process multiple assemblies, we have something to search for sensitive data, things for analyzing dependencies, detecting packers and protected assemblies, and looking at obfuscation techniques and stuff like that. And finally, we tell it when to use this kind of stuff. So that's the second part of a skill. So just quickly go over how we do this. So this first one is loaded all the time. This second block, the one we've just been through, with all the detail in, is loaded when Claude thinks it needs to use the skill. And the final piece for these is scripts. So these are executed in Claude's virtual machine. So Claude has a virtual host environment behind it that it does its stuff in. And it will execute these scripts in that environment on the files that you give it. So if we look at find sensitive, for example, it is using Python and a bunch of regex to look for private keys and AWS creds and JWTs and other stuff. It's not that complete a list, but it's a set of quick wins. Basically, if it matches any of these signatures, it's probably something that's going to be interesting to manually review. So scripts are what it will use selectively to do extra stuff, and these don't count for context use, if I remember rightly. So running the skill has some context use associated with it, but actually running this Python file in its virtual machine doesn't. It only starts using it again when it processes the output. That makes sense. So let's go back to my conversation here. So I left this up so we could go through how easier this was compared to doing it a few months ago with Claude Desktop. So there is some up here. This is me trying to just convince Claude that it had skills actually loaded. There are a few different places you can put skills in Claude and Claude Desktop. They are different depending on if you're using desktop.code. This is a project skill, so it's in a doc file inside the project folder, essentially. And this will be project specific. So if you were working on a dev project, you could have skills in there and they would be committed up to your GitHub or whatever you use, and it would stay with the project, and then multiple devs could work on it with the same skill. You can do global skills, just for sheer ease of use and time optimization. I just did a project one because it's easy. So once you get it to actually understand that it has skills, you can ask it to list all available skills, and it will realize that it has this IELTS by MCP, and it will give you that description block from the start. And then it will tell you a little bit about what it thinks this skill is for. So it knows that it has a skill related to its MCP that it will use to do .NET Assembly decompilation and analysis. So there, and I did the same thing. I gave it a folder of adin.util, and I gave it the same two files, adin.util, Bexy, and systemadin. And with one simple prompt, decompile and analyze them, use the MCP skill. So it will build this plan, and it will go through and start doing the stuff it needs to do. So it will find the binaries. It uses some search patterns and stuff like that to find the binaries in there. That's just kind of how this works under the hood. It finds the two binaries. It will verify that they are valid .NET files. So that was one of the steps we gave it in the skill. And it will tell you how it's doing it. And then it will decompile, add in DLL using IELTS by, and then the next step is going to be to do adin.util, which it will do. And then it will explore the structure. You can see it's what it's doing head 20 on here, but it will go through most of the files. So it's going to do a whole bunch of other stuff in there. It's working out of this decompiled folder, so we didn't need to tell it where that lives. It just now understands and knows. And the first thing it does is look for insecure deserialization patterns. That was one of the things that we told it to do. So I've not told it that these are the .NET deserializers, right? It just has this knowledge because it's been trained on them. So it has binary formatter, SOAP, contract data serializer, object state, and loss formatter. I've not told it specifically which one to use. So there's some more research to do here to see if it would find a vulnerable example of one of these. It's also missing some of the XML ones as well, which needs to be tweaked. But whether it would find one where it looked vulnerable but config meant that it wasn't. So that's another thing to do in the future. And then it's going to go through, carry on analyzing these files. So you can see it's already kind of honing in on this issue. It's found the binary formatter usage. It's looking in adin store. It's finding where the read cache method is called. So we recall from going through the original blog, this is where the vulnerability exists is in this read cache. So it's trying to figure out where that's called. So it knows that it needs to find the entry point to that function. It goes off in a bit of a tangent and looks at IPC channel and other stuff. And it goes and looks through like adding util. And then it would build a security report after it's done like additional vulnerability scanning. The important part here is not that it's doing all these steps, it's that it's doing them without being told to do them. Like from one prompt, which is all the way at the top, like go analyze the files in the edin util directory. It's gone through all these steps and it's producing this like markdown file with its, I'll call them findings in it. Why it's given it a CVS 9.8, I don't know. That's like something that will definitely need tweaking. I don't know why it chose to put a CVSS score on there, but it did find the binary format call. It did realize that the read cache method accepts, it reads files from disk with pipeline store and add-in store. It's figured out that context now that it has a couple of places where like we reached that vulnerable code, and it's essentially found both of those issues. Then it's got a few other things in there. So .NET remoting with type filter level full. This is the Netitude blog. I mentioned the previous one. This is their research essentially that it's still there and it's found that .NET remoting vuln. It's found a couple of other things in there like DLL hijacking, whatever else, like app domain creation and other stuff that I have just not had time to figure out why it's doing this or if these are valid or not. It is what it is. But it will generate this, detailed report for you. The step that I didn't do is ask it to build the POC for this. And again, there's a couple of reasons. I don't think going over that again is particularly worth it for demo purposes. Like we've done that already. And we're going to hit context limits if we start asking it to do stuff like that. So Claude is good at what it does, and it's getting to a point where unless you're paying $100, $200 plus a month for the higher level plans, it is just falling behind just based on these usage limits is my experience of it anyway. But doesn't mean it's unusable. The interesting thing will be to see if skills are ported into other agent systems. I did see something on GitHub a couple of days ago where somebody had a go at doing like an open source skills plugin that would work with Cursor, which is potentially quite interesting. But yeah, I've just not had the opportunity to really dig into that one yet. But yeah, that is all I had to show. So we've got 15 minutes or so for questions. If anyone's got them, I'd be happy to answer them.
Yeah, if anybody has questions on YouTube or on Discord, feel free to send them in now. Thanks, James, so much for that. Really appreciate it. And yeah, I'll give everyone a few minutes. Otherwise, we'll start to wrap up here.
Sounds good. I will at some point do a new blog on this, like the use of skills, and I'll make the code and stuff available when it's tidied up and in a state that I'm happy for other people to actually see. This was entirely vibe coded a couple of days ago, just for demo purposes basically. But I think there's definitely some scope there for this being fairly useful. I also just realized I didn't actually explain why we'd want to do this at scale. So apart from finding individual issues, like you find a .NET binary in your client's environment and you just want to quickly triage it and see if it's containing anything that might be useful for your engagement objectives. There is the other kind of angle of vulnerability research, like finding more issues like what's adding util. So as I did say, adding util is on pretty much every Windows install going. It's still vulnerable. I believe it's been reported to MSRC at least a few times, and it's a won't fix from them basically. So it's not going away, but if you can find novel ones of those, especially something like adding util, which has a path from an LNK file to code execution, essentially, if you figure out the steps involved. You can find novel ones of those in signed, trusted, widely used binaries. That's a huge win. Being able to automate a good chunk of that research means it can be churning away in the background while you're doing other R&D stuff, and it doesn't have to be this month-long effort to not get anywhere. You could just set an agent going on it and get a list of candidates that are actually worth manually exploring at the end. So that's why I'm trying to automate this as much as I can.
I don't think we have any more questions. So I think we're good to go there. Unless you have a final thought you want to close out with.
I don't, but thank you all for joining. If anyone does have questions that they think of later, feel free to tag me in the TS Discord. I'm more than happy to chat about this stuff whenever you like. So yeah, feel free.
Thanks very much. Yeah, feel free to send a message in the live events comments or just in general chat, and we'll make sure that we answer it. But thanks everyone for taking the time to join today. Everyone have a good holiday week next week. And yeah, have a great day, everyone. Thanks very much.